Graphs of the position functions of two particles are shown where t is measured in seconds. When is each particle speeding up and when is it slowing down, and then explain. Okay, well remember that when it's speeding up is when the velocity and the acceleration functions have the same sign, and it's slowing down when the velocity and acceleration have different signs. So let's take a look at our intervals. So we have going from 0 to 1, 2, 3, and then 4. So we have an interval that's going from 0 to 1, and then from 1 to 2, 2 to 3, and then 3 to 4. So we want to take a look at the velocity function. Now this is a position function. So the velocity function is telling us what is happening with this graph, meaning the position function. Well, we can see that the velocity is increasing in the interval between from 0 to 1. So for the velocity function, it's increasing. So we know it's increasing from 0 to 1. Okay. And then from 1 to 2, we can see that it's decreasing for the velocity function. So therefore, it's negative. And then from 2 to 3, it's still decreasing from 2 to 3, so we know it's negative there. And then from 3 to 4, it is increasing, so therefore we have a positive. Okay, now we need to figure out the acceleration. Now, when we're dealing with the position function, we need to look at where it is concave up and where is it concave down. So if we take a look from the intervals between 0, 1, and 1 and 2, we can see that it's concave down. And since it's concave down for the position function, that means it's negative from 0 to 1, and then from 1 to 2. And then if you notice from 2 to 3, and then 3 to 4, it is concave up. So therefore, it is positive here, and then positive here. So now we need to determine, okay, where is it speeding up? And then where is it slowing down? Okay, so recall that it's going to speed up when the velocity and the acceleration have the same sign. So we can see it has the same sign in the interval from 1 to 2. And we also see that it has the same sign for the interval between from 3 to 4. Okay, and then where is it slowing down? Well, we can see that the signs are opposite in the interval from 0 to 1. And they're also opposite in the intervals from 2 to 3. Okay, so now what we want to do is we're going to take a look at the second graph. Okay, so again, what we want to do is we want to find out and look at the intervals. Okay, so what is happening in these intervals? Well, again, we're going from 0 to 1 to 2 to 3 and then to 4. So we have the intervals going from 0 to 1, 1 to 2, 2 to 3, and then 3 to 4. And then since this is the position function, we want to determine what's happening with the velocity function, meaning what is happening in this position function. We can see it's decreasing from 0 to 1, so that means the velocity is negative. Okay, and it's also decreasing from 1 to 2, so therefore it is negative. And it continues to decrease from 2 to 3, so therefore it is negative. And then from 3 to 4 it increases, so therefore it's positive in the interval of 3 to 4. And then we're going to take a look at the acceleration function. Now remember, with the acceleration function, we need to look at the concavity of the actual graph. So if you take a look here, this is concave up for the interval between 0 and 1. So since it's concave up, it is positive in the interval from 0 to 1. And then from 1 to 2, then it's concave down, which means it's negative. And then from 2 all the way to 4, meaning between 2 and 3 and 3 and 4, we see that it's concave up. So therefore, it's positive for the acceleration function. So now we can determine where is it speeding up and where is it slowing down. Okay, well, wherever they have the same sign is where it is speeding up. So it's speeding up in the interval from 1 to 2, since they had the same sign there. And they also have the same sign in the interval from 3 to 4. And it is slowing down in the interval from 0 to 1, since they have opposite signs. And it's also slowing down in the interval from 2 to 3.